Hey students, this is Mr. Walsh giving you a little bit of a review on some molecular geometry stuff. And so normally I would be doing this alone, but today I have my nephew with me. He's right over my shoulder here.
Hello everybody.
Who are you?
I'm Joey.
He's Joey. He's my nephew. So he's going to help me out today. He's going to help you out, hopefully. Okay, so remember that the whole point of this unit is for you to be able to determine the molecular geometry of just about any molecule using Vesper theory. Vesper theory states that things that have similar charges will repel each other. Valence shell electrons will repel because their charges are the same. They're all negative. So that's what Vesper theory is. So let's just move on, and you may want to take out your notebook and just check that you have all these that are correct. And if you do, that's great, and you'll be ready for the assessment. So Joe, let's start with this molecule. This molecule has two atoms and it has one bond in there. Okay, there's electron domains, places where there's electrons, and there's bonding domains, places. Whoop, this guy's gonna roll right off of there. Maybe you can take and hold that guy right in the middle of the there. That's good. Yeah, but see how your hand's blocking the woo. Okay, there you go. That's even better. Okay, so so this is an electron domain and a bonding domain. So this has one electron domain and one bonding domain. Joe, what does that look like?
It looks like a linear line,
that's exactly what it is. It's a line, and there's only one of them, right?
Yes.
And so because there's only one of them, what does that mean?
It means there's no bond angle.
Right. You need two things to have a bond angle, right?
Mm-hmm.
You need to have two lines to have a bond angle. So when it's 1 and 1, we say that it's linear. And actually what we're going to say is anything with one bonding domain, whether it has 15 electron domains, 28 electron domains, 2 electron domains, anything with just one bonding domain will always be linear with no bond angle. So let's switch it up. Why don't we look now at 2 and 2, okay? So there's this guy with 2 and 2 here. And so 2 and 2 is the next up, 2 electron domains, 2 bonding domains. What is that shape?
That's a line too.
Yeah, it is a line. It's straight. Remember, the electrons want to be as far away from each other as possible,
yes,
because they're repelling. So when you put that in three-dimensional space, it's going to be a line. Okay, so this is a linear shape. But now notice there are 2 bonds there, and so when you have 2 lines, 2 bonds here and here, it actually does form an angle. And what's the bond angle in that case?
So the bond angle, I guess, would be 180 degrees.
180 degrees. That's exactly right. So now we can go down to 2 and 1 if we wanted to, but remember, anything with one electron domain, one bonding domain, will always be linear, and
no bond angle.
Has no bond angle, right? Because you need 2 things. So let's move on. Okay, so let's go to something that has 3 electron domains and 3 bonding domains. That's this guy. This shape is trigonal planar. Okay, trigonal sounds like triangle. So do you see how this thing can be a triangle? Okay, and the bond angle is?
It's 120 degrees.
120 degrees. It's 120 degrees because if you think about it, it's a circle.
It's split up into
three equal parts, right? 360 degrees, 3 equal parts. So that's 3 and 3. Okay, what if we go down to 3 electron domains and 2 bonding domains? So what if we replace that with this? Now we can see that these things are kind of similar. Okay, but we've removed one of the bonding places up here, right? And so by doing that, now the shape becomes,
it's a V shape.
It looks like a V, right? And so because it looks like a V, we call it V-shaped, right? Sometimes we call it bent because it's kind of bent. But what do you think the bond angle is?
So that would be 120 degrees, or maybe even a little less.
Yeah, it's still a little less. It's still 120 degrees because it's based off of 3 pairs of electrons repelling each other because their electrons have the same charge. So they're repelling each other, trying to get away as far as they want to. Okay, and so now remember, we go to 3 and 1. 3 and 1 is going to anything with one bonding domain. What shape is it going to be?
Linear.
Linear. And is there going to be a bond angle?
No.
No. Right. Okay, good. So we don't need to do the 1s anymore. But let's now look at this molecule. Okay. Okay, this has 4 electron domains and 4 bonding domains. Okay, this is the most common shape because there's 4 and 4. Atoms typically want to have 4 pairs of electrons around them. So this is how we equally space them in 3 dimensions. And we call this thing a tetrahedron. For the reasons, you can go back and review the previous videos. But this is called a tetrahedron. And Joe, are the bond angles 90 degrees there when I look at that going straight down?
No, I would say they're about 110 degrees.
Yeah, 110. The technicals, we're going to call it 109.5. Okay, they're not 120. Okay, so now if we get rid of one of the bonding domains, and so now we go down to 4 bonding domains with 4 electron domains and 3 bonding domains. You guys out there try to say electron domains and bonding domains for as long as I have and keep them straight. I defy you. Anyways, this is 4 electron domains and 3 bonding domains. I have shown the electrons that aren't bonding with that little paddle looking thing, okay? But notice when I do this, this thing is kind of it looks like a pyramid. So we call it pyramidal.
Pyramidal.
Right. And now it still has 4 electron domains, so the angle is going to be...
So then wouldn't it still be around 110 degrees?
Yeah, because it's still the same electrons pushing each other, so now it's still 109.5. Now, if you're really good, you'll know that it's probably 107 for this, but 109.5 is fine. Okay, so let's move along. So now we have 4 electron domains and 2 bonding domains, and so this guy... What are we going to call this guy? He looks familiar.
This guy's like V-shaped, just like the other one.
Just like the other one. But what's the bond angle?
Well, the bond angle is pretty close to the other one, 110, maybe a little less than that.
Right. And so let's compare real quick. Look, this is the one that is 3 electron domains and 2 bonding domains, and this is 4 electron domains and 2 bonding domains. This is the one that the bond angle is 120. This is the one with the bond angle of 109.5. And so they should be different. And so let's take and overlap them, and if you look, I'll overlap them. You'll notice that the angle of the one underneath is slightly bigger because that's the one that has 120 degrees.
Yes.
Yeah, right? So there's 2 different bents or V-shapes, each with a different different bond angle. Right. Okay, so now we get into the fun ones. Okay, so now we're talking about things with 5 electron domains and 5 bonding domains. This guy is crazy. This is called a bipyramidal shape. Now you'll notice that there's 2 different bond angles. As I look down at the equatorial bonds, you'll see that the angle between here is
90-degree angle.
That's this one, Joe.
Oh, that, okay.
This one here
is a 120-degree angle.
Yeah, because it resembles this guy, right?
Yes.
120. Okay. Now when we look down the axial bond, you'll see that this guy here is
a 90-degree angle.
90 degrees. So there's actually 2 bond angles here with this guy. Okay. And then we can move along. We can go to 5 and 4. And when we do that, we lose one of the equatorial bonds, and we call this guy, Joe, what do you think we call this guy?
Well, to me, it kind of looks like, almost like a seesaw type thing.
Yeah, it's seesaw. Look, boop, 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 boop. So that's why it's called seesaw. And just like the previous one, the bond angles are going to remain the same at
120 or 90 degrees.
Right. So now let's move along to 5 and 3. So when we have 5 and 3, now this thing is kind of flat. Now that thing looks like a letter. What letter does it look like?
Letter T.
It looks like the letter T. And what is the only bond angle now there?
And that only has 90-degree bond angle.
It only has 90 degrees. Okay, so now 5 and 2. Okay, we'll do this. 5 and 2. Joe, you know what it is what?
And that's just like the ones in the beginning. It's linear.
It's linear. Is there a bond angle with this one?
Yes, there is. And there's a 180-degree bond angle.
Right, because there are 2 bonds and not just one. Right, good. Okay, so now we're going to move along to 6, and this is the last one. 6 electron domains is the last one. Okay, now this guy is, with all of these things, is called octahedral. And again, if you want to know why it's octahedral, I'll tell you a little bit. You can go back and look at the videos. But this is octahedral, okay? What's the bond angle? If I look down, what does that bond angle look
No,
like?
this looks like an only 90-degree bond angle.
Yeah, no matter which way I orient this guy, the bond angle is only going to ever be 90 degrees. It's pretty cool, right? Okay. And so now let's go from 6 and 6, 6 electron domains and 6 bonding domains, down to 6 electron domains and 5 bonding domains. And so now this is that same sort of shape, except that shape now is missing one at the bottom. And when we do that, you can see that this guy looks kind of like a pyramid, right? And what shape is the base?
So it's like square.
It's square. And so what do we call that, do you think?
Well, it's square-based pyramid.
Yeah, it's a square-based pyramid, which is different than this guy. That's called just pyramidal. It's just a pyramid. This guy is a square-based pyramid. Okay, so you have to. It's a little tricky, but we can do it. It's pretty good. Okay, what's the bond angle?
It's 90-degree bond angle.
90-degree bond angle. So now let's do the next one, 6 and 4. 6 and 4 now. What does that look like?
So that's just a square.
Square, and it's flat. So in geometry, when it's flat, we call it planar. Right. So, and again, the bond angle is
90 degrees.
90 degrees. And then the last one we have is going to be 6 and 3. And 6 and 3, what does that look like?
So that looks like a letter T.
That looks like the letter T. Just like the one that we had with 5 and 3. It's the same thing. What's the bond angle there?
90 degrees.
90 degrees. Okay, so you can go back through and review this and get all the information, and that's every shape that you'll ever see. Is that cool, Joe?
Sounds cool.
Okay, well, see you later. Bye-bye.